Hey everybody, today we are going to be working on the scientific method lab in week 2. You'll need a few things out of your lab kits. You will need your scale. Some of them look like this, some of them are a little bit different, but all pretty much the same idea. What else are you going to need? You're going to need a measuring device of some kind. I've uploaded a meter stick that you can print out that's a PDF, so it should be fairly true. If you want to try to do that. However, you could also just use a tape measure if you want, or if you have a ruler, that's okay. Just be aware, I want everything in metric. So if you measure something and you say, okay, this was 2.2 inches, just go on to Google and type in 2.2 inches to centimeters. I think there's probably other things you're going to need, but we'll get to those as we get to them. So let's go here. We're in the course. Let's go to modules. I'm in the student view, by the way, so hopefully this is what you guys can see. Scroll down. This one's empty so far, but let's click on this one. Please download Complete the Scientific Method Lab, link above, to do Sunday before midnight. So let's see what it looks like. Oh, perfect. It's weird looking. Probably because I wrote it in Google Docs. That's okay. All right, so this is what the lab looks like. Wonderful. Okay, let's go back. And this is what the meter stick looks like. This open. All right, cool. Here's a smaller one that you may want to use. On one side is inches, on the other side is metric. But let's look at the lab here in Google Docs, which is how I recommend editing it. You can do it in Word too. It's just going to be slightly funny, just because I usually make these in Google Docs. So here's a definition of science. This is stuff that you should already be familiar with last week. Here is a rundown of the scientific method. This says purpose of today's lab. I put lines here to indicate that you should fill this in. I'm guessing most of you are going to type this, but if you want to print it out and write it, that's fine too. But I would recommend probably working on this after you're done with the lab. So here are some basic conversions in the metric system. So a meter is 100 centimeters, and that's the same thing as 1,000 millimeters, or 10,000, or I'm sorry, 1,000,000 micrometers. Micro is that little symbol right there. This is just some basic conversions. We're going to circle back around to these later on. Some more units. If you didn't know, 100 Celsius is the boiling point for water. 0 Celsius is the freezing point for water. If those seem very round, it's because that's how the metric system is. They're cool like that. You also have a thermometer in your kit, and I just want to get you to do some basic readings of a few things with that thermometer. I'm not gonna lie, I didn't know they were gonna be that sort of lame, but they will work. You can get a few measurements of a few different things. How cold is tap water? Just if you turn the spigot on, what's the temperature of your house? Then you're gonna get your scales out. Open up something like this, and you are going to take the mass of a penny. And since people probably don't have 100 pennies, I had to struggle to find one when I was trying to do this lab. Just go ahead and multiply whatever number you get by 100. I don't know why it's milligrams here, but that's okay. How many grams are 100 pennies? And then I want you to figure out what is the mass of one small glass of water. And what I mean by this is I want you to open up this scale, and I want you to actually tar it, or do what's called tarring it. So what I mean by that is I have my very scientific Jägermeister shot glass, and you can use a small cup, whatever you have is fine. Put it on there, and then press the power button to tar it. It's not going to work super well if you're holding it like this, so make sure it's on a flat surface. But then after you've done that, fill this up with water and put it back on the scale. and see how much this little container of water weighs. So you're also, after you've done that, I want you to figure out what the approximate mass, or the mass of approximately 5 mils of alcohol is. So you have your alcohol containers, okay? And this is, some of you might not be able to easily figure out what 5 mils is. And if that's the case for you, it's fine. You can just either estimate or you can just pour a little bit in and compare it to the water. So if you filled this thing all the way up, how much did the water weigh? If you fill it all the way up with alcohol, how much does the alcohol weigh? When you're done with that, please pour it back into your alcohol containers. That alcohol is going to be used later on this semester. And you also need this if you want to clean your microscope, which we'll talk about later this week. Go ahead and measure the diameter of a penny and then measure the length of your index or your pointer finger. This is going to be important for a later on thing we're going to do in this lab, so make sure you get index of your pointer finger. This one I realized folks may not actually have the ability to measure their height because that meter stick is not going to do it probably, but I kind of assume that most of us know what our approximate heights are, so you can just convert that to centimeters. Or you could like put a mark on the wall or do whatever you need to do. But yeah, get your approximate height. Get pretty close in centimeters at least. An aluminum can full of water contains how many mils of liquid? That's just you looking at the can to figure that one out. And then I want you to estimate the volume of a marble and estimate the volume of some small toy inside of your house. Yeah. So I want you to be thinking about how much space do these objects actually occupy? And I guess I should have asked you to attach a picture, but that's okay. Just maybe write down here what kind of toy it is. Okay, the next thing we're going to do is some more like mild data sharing stuff. So go ahead and go to this Google Sheets link here. And what I'm going to have you guys do is go ahead and fill in your data right here. Whatever, just fill in your data and then go up to File, make yourself a copy. And then that way, you've filled your data in, but you aren't messing with other people's calculations and you have everyone else's calculations, because there's a pretty good chance that a lot of you are going to be working on it at the same time. And so this will help with that, because other people will be like editing things and it will be pretty distracting. Here I have a bunch of fake students filled in along with some of my information, just in case, not just in case, this is for like the first people that do it so they can actually get some numbers. Okay, so they all need to be in metric, use the raw data, fill in these different numbers. The next thing I'm going to talk to you guys about is doing calculations in Excel or Google Sheets. It's the same thing, pretty much. But I wanted to talk to you guys about how you might go about doing that, because it says here like standard deviation of finger length, standard deviation of heights. And as soon as I start saying standard deviation, I know a lot of you guys are like, how do I drop this class? Where's the button to get out of here? Don't worry about it. It's not hard. I'm not going to make you do math like this, okay? I'm going to show you how to make Excel or Sheets do math for you, okay? So this is not going to be any advanced like mathematical reasoning or anything like that, okay? So let's go back to our Google Sheet. We have these data here, height, finger length, all that fun stuff. So our class average height, how do we figure that out? So you guys maybe remember how to figure out average is you would like add all these numbers up and then divide by the number of numbers. We're not doing that. All we're going to do is make the computer do some math for us. So how do we do that? The first thing to know about writing a function in Sheets or in Excel is it always starts with an equal sign. That was a test on my final last semester, or last spring, by the way. Whenever it was I taught this class last. So you always start with an equal sign. So what do you think the way to go about making it calculate the averages? Well, let's just start typing average. Oh, look, there's a function here for us called average. How convenient. So we're going to say, we'll start over. I'm going to type in right here for underneath where it says class average height. I'm going to type in equals average. And then I'm going to put in an open parentheses. So you hold shift and press 9 to get this. And I'm just going to click and drag and get all of these data. So our class average is about 176 centimeters so far. Okay, so let's do this a couple more times so you can see exactly how this process is working. So you start by typing in equals, and you type in average, and then an open parentheses. And then you can either click and drag to select your data, or you can tell it where your data are. So if you ever played Battleship, Excel works something like that. So our data start working in the cell C2, and they go all the way down through C8. So I'm going to say we're taking the average of C2, and then a colon, C8. Colon in this case means through. Or you could say, you know, C24 in case somebody plugs in more data later. But C2 through C8 is good enough for now. If you're doing this after me, which all of you will be, you'll need to include more data. So you'll need to include the data of the people that were like filling it in after you. So we'll do C2 through, you could even do C2 through C, which just says take the data of everything in this column, take the average of everything in this column. But there's a few different ways you can take averages. And let's do it again because we have to get our finger length, right? So I'm going to hit equals average, just like before, open parentheses. And where does our finger length data live? Well, it lives in D. It lives in this column D and beyond. So I'm going to say D2 through D, you know, whatever. We'll just say the other thing you can do is you can just say D through D, which takes the average of the entire column. If you're sure about all your data in there and you know that there's only like headers and stuff, you just take that data for the entire column. Okay. The stuff that people might be worried about, the height standard deviation or the standard deviation of your height. Well, this is exactly as easy as taking an average. So I'm going to hit equals STDEV C2 through C. There is our standard deviation. I'll do that a couple more times. Equals STDEV. That is our standard deviation. Don't worry about population standard deviation or sample standard deviation. We don't care about that stuff right now. I don't think we ever will, actually. So I've typed in equals STDEV, and I'm going to go ahead and just click and drag and get all these data, and in case anyone plugs in more stuff, we'll get that too. So how do you think we go about getting the finger length standard deviation? Pretty much the same, STDEV, D2 through D8. Or 100, it doesn't matter. You just need to make sure your data is there. We'll say D2 through D. Cool. So we have our heights, our average heights. We have our average standard deviations. So far, average height is 176.1. Average index finger length is, looks like 8.6. Sure, these are in centimeters. And by the way, your numbers should not be these exact numbers. So I'll know if you're just copying me, by the way, because you still have to fill in your data in that table, right? So standard deviation of heights, 8.8. This is also in centimeters. Standard deviation of finger lengths is 0.94. Okay, N, or the number of students used in this calculation. So I used 1, 2, 3, 4, 5, 6, 7 students in my calculation. So my N value is 7. Pretty easy, right? I mean, nothing too crazy. This is not like a statistics class. I just want you guys to see, hey, here's how I can make this program do math for me. This is how I can make it do what is probably some, not probably, Standard deviations aren't difficult necessarily to calculate by hand, but they're pretty tedious, and that's not what we're learning about. But anywho, that's how you make sheets do something for you, all right? So some questions about raw data and things. Now we're going to be constructing a graph of students' height versus their finger length. Okay, so let's go back to our chart here. And again, this is not going to be crazy difficult to construct a chart. All you're going to do is I'm clicking in C1 and I'm holding down the click and I'm just dragging down to get every student in here. So if we had somebody else in here, it doesn't matter, and they're this high and they have this long of fingers. Cool. Anywho, we're going to just grab all the data for all the students that are here, and we are going to go Insert, and we're going to go Chart. And this looks like a pretty true representation of our student height versus finger length. Okay, so I'll just have you go ahead and we're going to go Edit, Copy. We're going to go Edit, Paste. Wants me to use the shortcuts. That's fine. Paste unlinked, please. And there you go. Here is a graph of our raw data. Names should not be in here. It should just be height and finger length. Okay, then there are some questions about, is this hypothesis correct or incorrect? What did the class do to test this hypothesis? How could our experimental methods be improved? I can think of like 3,000 ways right off the bat. Just think of one or two. Did the data that was collected support the hypothesis? You tell me. Is there a trend here? Is this anything? Is this real? Describe, draw what your graph may have looked like if tall students had shorter fingers. That's an interesting one. And you can construct a hypothetical graph. Just make up some data. And in your data, tall students, so the taller people should have short fingers. And just show me what, you can paste that graph in or you can draw it if you'd like. I think it's probably going to be easier to just make up some data and paste that graph in. Show me what that should look like. If the data points are randomly scattered, okay, question for you. Okay, so changing units in the metric system. So this is something I'd like you to do, and it's going to be easy to just go online and look for these answers, but I don't think that's particularly useful to you. I think it's important to develop a somewhat intuitive sense of how these things work. So how many centimeters are there in 1.3 meters? How many kilograms or how many grams are there in 1.2 kilograms? So again, please don't just Google this. I know that that's available to you, but it's not useful at all, okay? And maybe I'll do a video later about how to actually do this. Anyway, that is the scientific investigation lab for you guys. Please let me know if you have any questions or comments or concerns or anything.